Hello guys, so today we're doing Leetcode's 242 valid anagram problem. It's a pretty good problem to start out with, and it says given two strings s and t, return true if t is an anagram of s and false otherwise. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. You can see in example 1, both s and t use the exact same letters, and this returns true. And in this one, S is rat and T is car, and it is obvious that they don't have the same letters, so it will obviously return false. And there's two solutions that I'll be introducing to you guys today. One of them will be just sorting the input. So let's use a smaller input, and let's not use this one because it's a little bit too long, but I'm going to show you guys like the basic. So S, let's say we have S as car, and we have T as rack. Right? Or even RCA. Let's pretend like this is a word. All you have to do is like return these two values sorted. So literally like return sorted S equal to sorted T. The time complexity of this will actually be n log n. So yeah. So let's say we sort this input, and we know it's going to be a boolean expression, right? We're not returning true or false. So if it's the exact same value, it will automatically return true. If it's not the exact same value, it will return false. So to sort it, it will be ACA and equal to ACA. You can see that this value sorted is the exact same value. So it'll return true. Yeah. Let's run it. And there you go. That's the solution. That's the first solution. Right? Another solution or approach to go with this is using a hash map. So let's say we put in a hash map. So a hash map is a data structure where it has like key and values, right? So let's put this value, anagram. Okay. So when we put this in a hash map, we're going to see there are 3 A's. And there are one N and one G and one M. Right? And we know that we have this word right here. So this is our table. We have this word. And we already confirmed that it is an anagram, right? So let's say that this is the exact same thing. We're basically going to zero out this hash map. And if the hash map is zeroed out, you return true. The time complexity of this and space complexity will be both O of n. But yeah, like I said, we're basically going to throw this all into a hash map. And we're going to actually throw S into the hash map. So we throw S into the hash map and we compare it with T. So basically with A, we have 3, right? So this is a hash table of S. So we're going to call it hash S, right? So basically, we have A is 3. We're going to go through this input right here and see how many A's are there. There's 1 A. So this will turn into 2. There's 2 A's. So this will turn into 1. It's basically we're subtracting it, you know? So we're going to decrement the input. So there's 3 A's. This is going to turn into 0. And so on. That's basically how we're going to be solving this issue. And once we solve it, to make sure this doesn't actually delete the key value pair, it's going to leave it in as A0. We're going to use a Python function called del or delete. It will delete both the key value pairs. So it will erase it from the whole thing. And it'll look like this after. So yeah, that's what we're going to be doing. So first, we're going to start off by initializing an empty hash map, or dictionary. And you're going to do a loop through S. So for I and S, if I not in hash S, right? So if I is not existing in hash S, you're going to want to add it. So hash S of I equals 1. Else it does exist. Let's fix this indentation. Else this does exist. You're going to do hash S of I plus equal 1. So that's how we're going to increment these values up to like 3 earlier, like we saw. Like this. Right? And now you're going to loop into you're gonna do for I in t. If I in hash s, so this is gonna check if I is actually in the hash map, right? So if I is in the hash map, you're gonna want to decrement the value. So actually, a better way to do it, if I is not in the hash map. So let's say if I is not actually in the hash map, like let's say that there was a t right here, and if there was no t in the hash map, we can just automatically return false, right? Right. And if I is in else, so this is the else statement where if I is in the hash map, right? So you're gonna want to decrement hash s of I, and if hash s of I equals 0, so if it gets to this scenario like earlier, I was showing you guys, if this becomes 0, you want to delete the key value pair, right? And to delete the key value pair, you're going to delete hash s of I. I'm pretty sure that's how you use the function. And then you'll return not hash s. Unindent. Yeah, this indentation. Yeah. Let's see. And you can see that this solution works. And it seems like it's actually a lot faster. But yeah, O of n time. Complexity. But yeah, hopefully you guys understood it. To like recap on this, we basically did a hash map. So we initialized an empty hash map. We looped through the hash map, and we added values, key value pairs from S. So we added these values into S onto this table. Next, we did another loop into T, and we decremented values from the hash map. And once it hits 0, you delete the key value pair. Just like this. And once it's empty, if the hash map becomes empty like this, you return true. So yeah. Hope you guys understood that.